Hi everyone, for my final project, I made a robot that can handwrite letters. I chose this problem because handwriting is a universal skill, but it's something a lot of people take for granted. But having a robot that can handwrite actually increases accessibility. It can save time and it can even be used in an educational setting, as we see on the right here. This image comes from a really interesting paper from the Georgia Institute of Technology showing the usefulness of learning from demonstration. For my specific implementation of this handwriting robot, I'm using the Ewa robot and the shrunk gripper hand. To represent a pencil, I have a cylinder in the image on the right. That's the object in yellow. And the writing surface is going to be this big purple wall. The pencil is actually welded to the robot's hand to simplify the problem a little bit. Given this setup, the robot is presented with a string, and then its task is to write that string on the wall. Here we have a couple pictures of the starting position. The bulk of my project came with the motion planning, creating a trajectory for the robot to undertake given the string. I'll let this video, one example of the robot writing a string, play while I talk about my implementation. So I actually created a list of key poses for each English letter, spaces and periods that rely on the position of the previous character to determine the poses of the new character. I then used Drake's linear interpolation tool to create a trajectory based on these key poses. It might seem like curves are hard given that I'm using linear interpolation. So I actually used a parametric ellipse equation and took sections of that to be able to create curves. To render this text after it's written on the wall, I used Matplotlib, which has a nice collection of lines functions. So I can check whether or not to render a line by seeing if one pose and the next pose are both in sufficient contact with the wall, knowing that if they are, linear interpolation would mean that the line connecting them should be rendered. I can then use that to choose what to render and get these nice images on the right. The bottom text is actually what the robot wrote in the video we just watched. For future work, I could possibly extend my robot to be explicitly used in education, perhaps waiting for a student to write a character after it demos it. I could also use machine learning to switch from a static implementation of characters to kind of a new framework where the robot is able to teach itself characters. Thanks for a great semester.